The essential question today is how do I solve problems with whole numbers? Now, a whole number is defined as all of the natural numbers and zero. Natural numbers are the ones we learn to count as babies. They're the ones we learn to count naturally. So as a baby, you start off 1, 2, 3, 4, and so on. With whole numbers, what we add in is the concept of zero. Babies don't understand the concept of zero. All right, so zero is not part of the natural or counting numbers. The first major topic we're going to talk about in these notes is how do I add whole numbers? When you add whole numbers, you have to line up the place values. So that leads us to a brief reminder of place values when you do not have a decimal point. So let's look at this number. When I read this number, I read 987,654. There's no decimal point here. The decimal point is technically right after this 4. That means the 4 is in what we call the ones place. Sometimes you see it called the units place value. Then we move to the left as we name each additional place value. The 5 is in the tens place. The 6 is in the hundreds. The 7 is in the thousands. The 8 is in the 10,000s. And this 9 is in the 100,000s. The next place value would be the millions. Okay, and we would keep going from there. So as we look at our first addition problem, we have 465 plus 27. And this is written horizontally or side to side. When you add whole numbers or decimals, you really need to add vertically. So we're going to rewrite this problem. 465 plus 27 equals. I've lined up the ones place. In both numbers, it was the last digit. So the ones are all in a column going up and down. The tens are all in a column. And then I've only got the one digit, the 4, in the hundreds place. So we start on the right and we work our way to the left. We add 7 plus 5 is 12. Put down the 2, carry the 1. 1 plus 6 is 7, plus 2 is 9. There's nothing to carry this time. And 4 plus nothing is 4. So the answer is 492. So I look at my next problem. It's 13 plus 2,456. Yeah, I've got the 3 in the ones place and the 6 in the ones place. So this is going to help me set up my columns. I like to put the number with the most digits on top. There's no mathematical reason for that. It's just the way I was taught when I was a little girl. So 2,456. And when I line this up, I need to make sure the 3 is under the 6 and the 1 is under the 5. 6 plus 3 is 9. 5 plus 1 is 6. 4 plus nothing is 4. And 2 plus nothing is 2. 2,469 is our answer. For my third addition problem here. I've got three numbers to add together. In 23, 3 is in the ones place. 974, 4 is in the ones place. 7,812, the 12 is in the ones place. And again, I like to put the number that has the most digits on top, and that's just a habit. So 7,812. Now when I write the 974, I need to make sure the 4 is underneath the 2, the 7 underneath the 1, and the 9 underneath the 8. So that I've got the ones, the tens, and the hundreds in a column. And then the 3 will go under the 2 and the 4, and the 2 has to go in the tens column. So starting on the right, 2 plus 4 is 6, plus 3 is 9. 1 plus 7 is 8, plus 2 is 10. Put down the 0, carry the 1. 1 plus 8 is 9, plus 9 is 18. Put down the 8, carry the 1. 1 plus 7 is 8. So 8,809. Now at this point, you can turn in your packet and do the adding whole numbers practice, or you can keep going with the notes. It's your choice. Next up, we are going to talk about subtracting whole numbers. And so our question is, how do I subtract? Whole numbers. It's our second major topic. In these notes. Okay, again, to subtract whole numbers, we have to line up the place values. So, as I look at our very first problem, 786 minus 24, the 6 and the 4 are both in the ones place. With subtraction, it is important that you order your numbers from left to right. So the number on the left, 786, will have to go on the top. And then I need to carefully line up my place values, one place, tens place, as I write the second number. Okay. Again, starting from the right, 6 minus 4 is 2. 8 minus 2 is 6. And 7 minus nothing is 7. For our next example, 5,632 minus 412, we have 2's in the ones place for both numbers. Going from left to right as I rewrite the problem, I have to make sure with the second number that I line up my place values, ones, tens, and hundreds. So, starting on the right, 2 minus 2 is 0. 3 minus 1 is 2. 6 minus 4 is 2. And 5 minus nothing is 5. With subtraction, you have to be careful. Sometimes you have to borrow or regroup from a larger place value. Borrow and regroup has the same meaning in this situation. When I went to school, I was taught you borrow from the tens place, or you borrow from the hundreds place. Now that I've got children in school, they call it regrouping. You regroup from the tens place, or you regroup from the hundreds place. So a lot of it depends on what you were taught when you were in school, but keep in mind that if you have children, they're being taught the word regroup and not the word borrow. As I look at the first problem, 2,345, the 5's in the one place, minus 47, the 7's in the one place. So 2,345, and then line up the ones, line up the tens, and I am subtracting. All right, 5 minus 7. That's a little bit of a problem because if I only have $5 in my pocket, I can't spend $7. Right? So I'm going to borrow or regroup from the tens place. I'm going going to take away from the 4 and make it a 3. And I'm going to add that 10 to the ones place so that now I have 15. And 15 minus 7 I can do. 15 minus 7 is 8. 3 minus 4. I've got a problem again. So I'm going to borrow or regroup from the 100s, adding 10 to the tens place. 13 minus 4 is 9. 2 minus nothing is 2. And 2 minus nothing is 2. For our next problem, 756 is in the ones place. Minus 99, that last 9 is in the ones place. So writing it from left to right. Okay. 6 minus 9. Gonna have to do some borrowing here. So I'm going to take away from the 5 and add 10 to the ones. 16 minus 9 is 7. 4 minus 9, again, I'm going to have to regroup. Take 1 away from the 7 and add it to the tens place. 14 minus 9 is 5. 6 minus nothing is 6. I believe this is our last subtraction problem. 1090, with this last 0 being in the ones place, minus 156, with the 6 being in the ones place. So 1090, 6, and then 5, and then 1, lining up my columns. All right, 0 minus 6. So again, I'm going to have to regroup here. I'll take 1 away from the 9, and I will add it to the ones place. So 10 minus 6 is 4. 8 minus 5 is 3. But now I'm trying to do 0 minus 1 again. So I'm going to take away from the place to the left and add 10 to that place value. 10 minus 1 is 9. 934 is our answer. At this point, you could turn in your packet and do the subtraction practice, or you can keep going with your notes and do all of the whole numbers practice at the end of the lesson. All right, the third section of our notes is multiplication. How do I multiply whole numbers? To multiply whole numbers, begin by lining up the place values again. Place value plays a very important role in computation. Remember, we have a number of different symbols that all mean multiplication. In elementary school, children are taught in X, but in algebra, we're going to use that X as a variable. So in algebra, we really want you to transition to a dot. You'll also see parentheses with a number outside the parentheses and then a number inside, like down here. That also means multiplication. Okay, so we've got 3 different symbols that we're going to use for multiplication in this lesson. And you do have to know all 3 symbols. 23 times 7. 23 times 7. Again, we start from the right-hand side. 3 times 7 is 21. Put down the 1, carry the 2. 2 times 7 is 14, plus 2 is 16. Our answer is 161. For our next problem, 465 times 92. This time we're using the dot instead of the little x for multiplication. Starting from the right-hand side, 2 times 5 is 10. Put down the 0, carry the 1. 2 times 6 is 12, plus 1 is 13. 2 times 4 is 8, plus 1 is 9. Now, when I go to multiply by 9, I have to put in a placeholder 0, because when I multiply by 9, I'm really multiplying by 90, the place value. So I need a 0 to hold this spot. 9 times 5 is 45. Put down the 5. Carry the 4. 9 times 6 is 54. Plus 4 is 58. Put down the 8. Carry the 5. 9 times 4 is 36. Plus 5 is 41. We have to add these two together. 0 plus 0 is 0. 5 plus 3 is 8. 9 plus 8 is 17. I'm going to have to carry the 1 there. 1 plus 1 is 2. And nothing plus 4 is 4. So 42,780. Not our last multiplication problem, but our second to last multiplication problem is pretty big. So I'm going to start it over here. 2,631 times 843. And I'm going to use the dot since I'm going vertically in terms of my format. Okay, remember the number right up against the parentheses means we're multiplying the two values together. All right, 3 times 1 is 3. 3 times 3 is 9. 3 times 6 is 18. Write the 8, carry the 1. 3 times 2 is 6, plus 1 is 7. So I'm done with that 3. And I'm going to put a placeholder in the ones place. 4 times 1 is 4. 4 times 3 is 12. Put down the 2, carry the 1. 4 times 6 is 24, plus 1 is 25. Put down the 5, carry the 2. 4 times 2 is 8, plus 2 is 10. And I'm done with that one. This time I need 2 placeholders. All right. 8 times 1 is 8. 8 times 3 is 24. Put down the 4, carry the 2. 8 times 6 is 48, plus 2 is 50. Put down the 0, carry the 5. 8 times 2 is 16, plus 5 is 21. Now I've got to add these 3 rows together. 3 plus 0 is 3. 9 plus 4 is 13, plus 0 is still 13. 8 plus 1 is 9. Plus 2 is 11, plus 8 is 19. Carry the 1. 1 plus 7 is 8, plus 5 is 13, plus 4 is 17. 1 plus 0 is 1. 1 plus 1 is 2, and 2 plus nothing is 2. So as we look at this, if I put in the commas to make that number a little more readable, 2,217,933. I'd like to have that much money. Our last multiplication problem, this one has a number of zeros in it. 4,002 times 360. All right. 0 times 2 is 0. 0 times 0 is 0. 0 times 0 is 0. 0 times 4 is 0. I like that route. Now I'm going to need a placeholder. So 6 times 2 is 12. 6 times 0 is 0, plus 1 is 1. 6 times 0 is 0, and 6 times 4 is 24. Now I need 2 placeholders at the end. And 3 times 2 is 6. 3 times 0 is 0. 3 times 0 is 0. And 3 times 4 is 12. I'm going to add that all up. 0, 2, 7, 0, 4, 2, 1. 1,240,720. Now, take note that in many countries, you use a decimal point to show where you pause as you read those place values. But here in the United States, we use commas. Okay, so where in your country, you may have to flip what you're used to as a decimal point and a comma. Something to think about. All right, again, you can pause the notes here because this lesson's getting very long and do the multiplication practice, or you can push through with this lesson and go ahead and do the division notes, which is our last stop, our last topic. How do I divide whole numbers? I like to use a mnemonic when I'm doing division. Mnemonic is just a memory device. It's a phrase or a saying that helps you remember how to do something. I use the mnemonic, does McDonald's serve burgers? To help me remember the steps. Okay. Divide, does. Multiply, McDonald's. Subtract, serve, bring down, burgers. So by using the first letter in the mnemonic, it can trigger my memory and what steps to do as I'm solving the problem. So we've got a number of symbols that mean division. You see this division symbol and also this division symbol very frequently in elementary school. What you need to remember is that the fraction, written either way, is also a division symbol. So a fraction bar also means to divide. And that's something that people forget all the time. I'm going to go ahead and put some letters up here so that you don't think that's subtraction or a backslash. Okay? But fraction is truthfully division problem. So let's take a look. 124 divided by 5. Now, when I do long division, I always write it with the what we call the house symbol. So 124, the first number goes inside the house, divided by, which is the house symbol, and then 5 goes outside the house. The 124 is called the quotient, the dividend. The 5 is called the divisor, and then our answer is going to be called the quotient. And we'll go over those words again as we go. But does McDonald's serve burgers? So my first step is divide. Can I divide 5 into 1? No. I can't split 1 up into 5 parts. So I'm just going to put a little X there to hold my place. That's not possible. Can 5 go into 12? And the answer is yes. It goes in 2 times. The next step is multiply. 2 times 5 is 10. Next up, subtract. 12 minus 10 is 2. Next up, bring down the 4. 5 goes into 24 4 times. That's my division. Now I need to multiply. 4 times 5 is 20. Next up is subtract. 24 minus 20 is 4. And I have nothing left to bring down. So I have a remainder of 4. And here is my final answer. 24 remainder 4. So 124 is called the dividend. 5 is called the divisor. 24 is called the quotient. And 4 is called the remainder. And I'm going to write these vocabulary in. Dividend. This is my remainder. The leftovers, it's the part you couldn't split up evenly. The 24 is my quotient. And the 5 is a divisor. All right, next one. This one is set up nicely for me, except that it's way too small for my handwriting. So I am going to rewrite it over here. 2,934 divided by 7. Does McDonald's serve burgers? All right, first step is divide. Will 7 go into 2? And the answer is no. But 7 will go into 29 4 times. Next up, multiply. 4 times 7 is 28. Next, subtract. 29 minus 28 is 1. And then bring down the 3. 7 goes into 13 1 time. That's my division. 1 times 7 is 7, my multiplication. I need to subtract. 13 minus 7 is 6. And I need to bring down the 4. All right, 7 goes into 64 9 times. 9 times 7 is 63. 64 minus 63 is 1, and I have nothing left to bring down. So 419 remainder 1 is my final answer. 291 divided by 13. 291 goes in the house, divided by 13. This one's going to be a little tougher. Does McDonald's serve burgers? That's just a little harder because I have a divisor of 13 instead of a single digit divisor, but we can do it. Does 13 go into 29 or 20? Does 13 go into 2? And the answer is no. But 13 does go into 29 2 times. 2 times 13 is 26. And 29 minus 26 is 3. Bring down the 1. 13 goes into 31 2 times. 2 times 13 is 26. 31 minus 26 is 5. And I have nothing left to bring down, which means I'm done. 22 remainder 5 is my final answer. Our last problem for this set of notes. 4,963 divided by 3. Does McDonald's serve burgers? 3 goes into 4 1 time. 1 times 3 is 3. 4 minus 3 is 1. Bring down the 9. 3 goes into 19 6 times. 6 times 3 is 18. 19 minus 18 is 1. Bring down the 6. 3 goes into 16 5 times. 5 times 3 is 15. 16 minus 15 is 1. Bring down the 3. 3 goes into 13 4 times. 4 times 3 is 12. 13 minus 12 is 1. And I have nothing left to bring down. So I have a remainder of 1, and my answer is 1,654, remainder 1. So our summary on this note, on these notes, we really want to bring out the main ideas. And the biggest idea is to add, subtract, and multiply. Make sure you line up the place values. with all four operations, we want to always use a vertical format. All right, at this point, we have several worksheets to do on whole number operations. And then you either have a page in your textbook or an IXL section to complete.